All right, this is why I think limits are confusing. Sometimes you come to these and you're like, oh my gosh, like where do I start?
When it's by the left side, like how
okay,
would you...
is that little negative right there?
Yeah.
That just means we're going, we're finding a limit, like a one-sided limit. So this is coming from the left side. So coming from the left side, what is this limit?
Negative.
Yeah.
So
well,
it's just...
is it negative or positive? I don't know.
Oh.
So this is what we're gonna do. First thing I want to do, because we should always do this, is just plug in 4 and see what we get. So let's plug in 4 to see if we get anything. This would be 10 on top if we plug it in.
Okay, that's good.
We would get 10, and if we plug 4 in on the bottom, it would be 16 minus 24 plus 8. Well, 8 and 16 is 24, so it would be 24 minus 24, which is undefined. Okay, so the limit doesn't exist. This is not indeterminate, so it's not like we can manipulate this to find the answer. We just know that the limit doesn't exist. But there is no D and E for a solution over here. My guess is it's probably going to be one of these. It's going to be a positive infinity or negative infinity because I got a D and E. All right, so let's think about this for a second. 4, because we got 0 on the bottom, must be an asymptote for this function. For this function, we have an asymptote at 4. Here, let's factor the denominator really quick. On the top, we have x plus 6. On the bottom, we have x minus 2, x minus 4. Okay, negative 4 and negative 4 and negative 2. When I multiply those, I get a positive 8. When I add them, I get a negative 6. So an asymptote at 2 and 4. So at 2 and 4, we have an asymptote. Boop, 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 boop. So something's happening before the 2, between the 2 and the 4, and after the 4. And we could figure out what's happening in every single one of these just by plugging in x values. But I really don't care. I only care what's happening at 4 as we go from the left. So are we going like this, or are we going like this? Are we approaching positive infinity or negative infinity? If the arrow's pointing up, that'd be positive infinity. If the arrow's pointing down, it'd be negative infinity. So how do we do that? How do we figure that out?
Plug in 4.
Yeah, we got to plug in numbers. So first thing we do is we would plug in 3.9. Actually, let's just plug in 3. And then we'll plug in 3.9. And then we'll plug in 3.99. We're going to need a calculator for this. Yeah, we need a calculator. No, should we do fractions?
No.
No, don't do fractions. Okay, so let's plug these into a calculator to see what we get. And then this would be my y value, x value. Okay, so I have my graphing calculator here, and I pressed y equals. I plugged in my function. Notice that I put parentheses around the numerator and parentheses around the denominator. That way the calculator knows what goes on top and what goes on bottom. And then I'm going to hit graph. All right, I can't see anything, so I'm going to zoom standard to make sure that I can. Yep. Okay. So when I hit zoom standard, the graph then goes negative 10 to positive 10 on the x-axis, and then negative 10 to positive 10 on the y-axis. Now I'm looking at 4 right here. This is where my asymptote is. It looks like there's just a parabola that's facing down. So that means our answer is going to be negative infinity. What if you couldn't see the graph though? How would you figure this out using the table like what we wanted to do? So what you would do is you would click on or push table, and then you have to make sure that you're on ask. Here, let me show you really fast where that is. If you go to table set, you make sure that the independent variable is on ask. That way you can plug in any x value you want. So I'm going to plug in 3, and then plug in 3.9, and then plug in 3.99. Oops. And then the other one, 3.999. And look what I'm getting. Look at our y values. What's happening is dramatically going down more negative. That is analyzing the problem numerically, and that gives it away. That tells us that we are approaching negative infinity for this limit. Okay, so now let's go over to number 8. Another limit, but make sure you're paying attention to what the limit is saying. It's saying it's an infinite limit. As we go to the left side of the graph, that's negative infinity. What is this graph going towards. So first, we just want to plug in negative infinity to see if anything cool happens. Now, you just got to think about each of the x's, and if you take them to negative infinity as it gets bigger, bigger, and bigger, what are you approaching on the top? So if I look at the bottom, or the top, if I plug in gigantic negative numbers, and right next to this 3, we would go 3 times a gigantic negative number. And actually, this plus 2 doesn't even matter anymore. I mean, like, if this is a gigantic negative number, that plus 2 is barely going to make a dent. It's not going to make any changes. So top, we're approaching negative infinity. The bottom, you're taking negative infinity and you're squaring it. What does that happen? What does that do to the negative number? It makes it positive. So we have a gigantic positive number, and then we're adding 4 to it. And then we're square rooting it. Now, adding 4 barely does anything to a gigantic number. Like, if you had $1 million and someone gave you $4, you don't care. That's nothing. And then you square root the number. Okay, so square root makes it smaller, but you're still at infinity. So we're at infinity over infinity. I know the top's negative infinity, but it doesn't matter. It's infinity divided by infinity. So it's not -1. That's what some people think right away when they have negative infinity divided by infinity. They think, oh, it's -1. No, it's not. So what we're going to do is we're going to manipulate this a little bit. Since we got an indeterminate form, we're going to take something out of this square root. Normally what you do, if there was no square root, you would divide everything by the highest degree on the denominator. So like, let's say that square root wasn't there. If that square root wasn't there, you would divide every term by x squared. Or you would multiply everything on the top by x to the -2 and everything on the bottom by x to the -2, which is the same as dividing it by x to the second power. But because there's a square root, that makes manipulating a little bit more fun. So what you're going to do is, because there's this rule that says if you have 2 numbers multiplying to each other inside of a square root, you can split it up. We're going to do that. We're going to take this square root and we're going to split it up. So let's go inside our square root for a second here. We have x squared plus 4. I want to take out from this an x squared. So that would make this a 1, and that would make this a 4 divided by x squared. Okay, you guys with me? Now I have the x squared and the 1 plus 4 over x squared multiplying to each other. It's kind of like this guy's the a and this guy's the b. And I'm going to separate them. So now let me rewrite what I have so far. Let's clean it up. We have 3x plus 2 divided by x, or square root of x squared, and the square root of 1 plus 4 over x squared. Okay, so we did this stuff so I can do this. I wanted to take out a square root of x squared. Do you guys know what the square root of x squared is? It's just x. So now I want to divide everything by x, because this is the greatest degree. So I'm going to multiply everything on the top and everything on the bottom by x to the -1. That's the same as dividing by x. So when I do that, let's see what we get. When I multiply to the first term, it would be 3x to the 0 power. When I multiply to the second term, it's going to be 2x to the -1. On the bottom, it looks like we have 2 terms right here, but we don't. Because they're multiplying, I only have to multiply to one of these terms with the x to the -1. So I'm going to multiply it to this. So that would be x to the 0 power, and then it's multiplying to the square root of 1 plus 4 over x squared. All right, now I wrote extra here just to try to help you guys see and understand. What's x to the 0 power? You guys remember anything into the 0 power? Do you guys remember what that is? It's 1. Anything to the 0 power is 1. So this is just 3 times 1. And then if you have x to the -1, that's the same as 2 over x. So you have 3 plus 2 over x, and on the bottom you have the square root of 1 plus 4 divided by x to the second power. Okay, so what would we get if we took this limit as x approaches negative infinity? Let's think about this. Let's go to this first x right here. If I'm plugging in gigantic negative numbers to this, like this number is getting huge in the bottom, what is this approaching? What is this fraction going towards? I mean, like if I wrote 2 over 3 with a bunch of zeros after it, what is this number really close to? It's super tiny. 2 to the 3 billionth? Okay, that's nothing. That's a 0. It's going to 0. And that number on the bottom is getting bigger and bigger and bigger. So whenever you have a variable in the denominator, you know this is going to 0. So this number is insignificant when we go to infinity. Same with this fraction. I mean, it's even going to 0 faster because x is being raised to the second power. So this is going to 0. Gone. So now what are we left with? We're left with 3 over the square root of 1. And what is the square root of 1? 1. What is 3 divided by 1? 3. So that's your answer. Now that is a horizontal asymptote for this guy. Because we're approaching a finite number, we know that we have a horizontal asymptote at 3.